All right, we're going to move on to empirical formula. So let's define that before we continue. A lot of times I just like to write EF because, saves time, right? And so this is the smallest whole number. So smallest whole number ratio between the elements in a formula. Smallest whole number ratios between elements in a formula. So your actual answers are always going to be in a formula. In order to do this, I have a poem here that I found, and it's going to help us and guide us in how to do this. So let's take a look at what this means on this first problem. In this first problem, it's asking you to calculate the empirical formula, and it has these elements in it. Your actual answer for this problem is going to have some type of ratio calculated to be able to insert into these spots. So this will be my final answer when I'm answering this. I'm giving this as my empirical formula, smallest whole number ratios between these elements. Okay? So let's take a look. They've given it to us in percent compositions. And it says here, all right, we're going to follow this poem. It says percent to mass. Now, when I add up all of these, should be about 100%, but as we saw on the percent composition, depending on how many decimal places you carry, it might be a little bit more than that. All right, so percent to mass, the first line, I'm literally going to take this number and change it to a mass. Now, remember, it should have a mass with a unit with an element. So that's for carbon. I'm doing this for nitrogen. It becomes grams nitrogen. All right, percent to mass. I'm going to take this oxygen and change it to a mass oxygen, 14.14 grams. And for my hydrogen, it's 9.80 grams hydrogen. So each of these percentages have been changed to mass, as the first line asks us to do, percent to mass. Now the next one says to take those masses, it says mass to mole, which is saying take these masses and change them to moles. So I'm going to do this first one like this, where I use these hatch marks. Remember, you're multiplying everything on the top, and then multiply everything on the bottom, divide it to the top. All right, so I'm going to use those mole facts, where it's 1 mole of any element is equal to its atomic mass, because I'm trying to change grams of an element to moles of an element. When I write it over here, make sure everything has a unit and a substance. The key to changing the mass to moles is to make sure you have 2 decimal places on your mole answer. All right, in this next one, I'm going to change grams of nitrogen to moles of nitrogen. So 1 mole of an element is equal to its atomic mass, so that's the fact. I'm just putting it in there so that the words and the units cancel out. Now, some students don't like the hatch mark method, so I'm going to do one here if you like this look of it better. 1 mole of an element is divided by its atomic mass, and I get 0.88 moles of oxygen. Yes, those have the same answer. And again, I'm going to go back to the hatch marks so I don't write so neat. It helps keep my writing at least fairly organized. And then again, different periodic tables might have slightly different atomic masses, so don't get hung up on that. Just make sure you're using that fact that 1 mole of any element equals the atomic mass, and have 2 decimal places when you change it to moles over here. So we've only done the first 2 lines. We went percent to mass, mass to mole, and then it says divide by small. Now sometimes this is where you will stop. This is where you get the ratios between the elements and you just insert them in here. But sometimes they don't work out so nice and neat, and we'll do one here where we're going to use the last line, multiply to whole. But let's do this one. It says divide by small. So what you're doing is taking the smallest number of moles and dividing it into each. So 0.88 is the smallest. So I'm going to put that in there. And it gets divided into each. This one will be 6. When I do the division, that equals 1, that equals 1, and this actually equals 11.1, which you're like, well, that's not exactly 11. It's close enough. It is close enough to 11. We're good with that. So these are the small whole number ratios between all of these elements, and I'm going to write them here. I don't care what order you write your answer in. If you started with nitrogen and then did oxygen, carbon, hydrogen, it doesn't matter. All I'm looking is that the ratios fit to whatever element they're supposed to go to. So 6 is with carbon. All right, now you don't have to write the 1 next to nitrogen and oxygen, but if you want to, you can. I'm doing it just to show you that we did calculate it. And then there's an 11 by the hydrogen. This is your final answer to doing all of this. Percent to mass, mass to mole, divide by small. This is where you develop your ratios. I did not have to do that last line, that multiply to whole yet. Now, is this the actual chemical formula for those elements? No. This is called an empirical formula. I mean, sometimes empirical formula is the actual formula, but I'm going to show you why that falls apart. So there is another thing called the molecular formula, which we will not be covering. All right, that is the actual formula of the compound. So let's just say that I did all this work up here, okay? So I'm going to write it over here, actually. I'm going to write my empirical formula. I did all this work between carbon and hydrogen. Remember, I'm making this up. And I saw that they were 1s, C1H1. That was the smallest whole number ratio. This other calculations that you have to do to get the actual formula, and we're not showing that, I determined it was C6H6. Isn't that a 1-to-1 ratio between those two? That's what this is saying. That's a 1-to-1 ratio between them. Whatever extra calculation had to do to find the actual formula, here's what it actually was. So sometimes empirical formula will be exactly match the molecular. A lot of times it does not. Okay? All right, let's move on to the next page to do some more sample ones here. All right, so we're trying to find a formula between potassium, chromium, and oxygen. All right, so whatever our answer is going to be, it's going to be in that type of a format where we're going to put the values in there. So I like to line them up when they give it to me like this. I like to put the information just kind of how we solved it on the previous problem. So there's the 26.6%. Chromium is 35.4%. Now, I want to just take the moment to tell you, a lot of these like to omit the percent on one of the elements. So let's say it told me it had oxygen in it, but it didn't give me a percent. But remember, I told you all the percents are going to add up to 100% approximately, right? So if the oxygen was missing, you could have taken 100% minus that information to determine what oxygen was. So just be on the lookout. They like to do that a lot. All right, so I've taken this information and put it down like this, and I'm going to follow the poem where it says percent to mass. So I'm going to change the percents, and remember, we need to have a unit and a substance. Change the percents to masses. All right, and then change the percent. Is that 38? Yeah, 38.0 grams of oxygen. I'm just going to keep using that poem. All right, percent to mass, mass to mole. So I'm going to take the 1 mole of any element is equal to its atomic mass. and I'm going to carry at least 2 decimal places. All right. All right, this is 0.680. 2 or 3 decimal places is fine. I'm going to take chromium. So 1 mole of chromium has atomic mass of 52.0 grams. Again, 1 mole of any element equals its atomic mass. We really should be canceling as we do it because those are checkpoints. And this is going to be 0.681 moles of chromium. All right. You can pause it and do it for oxygen and see if we match. Or you can sit here and watch in just a couple seconds of me solving it. All right, 1 mole of oxygen has an atomic mass of 16 grams, and it's 2.38 moles of oxygen. So far we've only done percent to mass, mass to mole, and then it says divide by small. Well, really, I mean, yeah, technically it's this one. They're basically the same, right? So I'm going to divide 0.680 moles into each of these because that is the smallest number of moles. This is the divide by small. So this value will be 1. This will be 1. And when I do the oxygen, I get an answer of basically 3.5. It might be 3.49, it's 3.5. This is how it's going to look like for exams or quizzes when we're going to have to use that last line that says multiply to whole. This is not a 3 or 4. You can't round up or round down. So we need to multiply it to get it to a whole number. So if I multiplied this by 2, I would get a value of 7. That is multiplying to whole. That's that last phrase. But what I do here, I need to do to these also. So I need to multiply this by 2 also and this by 2. I am now done with the information. So I'm saying it's K2 CR2O7. Those are my smallest whole number ratios. Okay? All right, you can stop the video and you can solve this on your own and then hit play to see if we match. Remember, you're trying to find the whole number ratios between carbon, hydrogen, and oxygen. All right, feel free to stop, work it out, see if we match. All right, I'm going to do the same thing here as I have been doing, as I'm going to take the information and I like to stack it into a line like this. Ooh, percent hydrogen. Sorry, my units are getting away from me as I'm looking at my answer key. Okay, this one didn't tell you oxygen. All right, but you could find that by taking the 100% and minus the 40% plus 6.67%, and you would have gotten 53.33%. So this missing piece of information is 53.33% oxygen. Okay? All right, so we're going to change this to mass. So this is 40 grams of carbon, 6.67 grams of hydrogen, and 53.33 grams of oxygen. Percent to mass. Mass to mole. So 1 mole of carbon divided by 12.01 grams of carbon gives you 3.33 moles of carbon. 2 decimal places, unit, substance. All right, changing this to moles, 1 mole of hydrogen. Now I use 1.01 grams of hydrogen. I might have grabbed a different periodic table when I was solving this. 6.60 moles of hydrogen. All right, now we're going to get this oxygen to moles of oxygen, and that's 3.33 moles of oxygen. Percent to mass, mass to mole, divide by small. So 3.33 is the smallest number of moles. You have to divide it into each. All right, the first one is a 1, the second is a 2, and this other one is a 1. So our final answer will be C1H1 C1H2O1. C1H2O1. Again, I don't care if you don't put the ones on here. And I don't care if we are doing things differently in an order. All right, so that is the empirical formula. There is some more practice problems here that you can do, and it's giving you what the answers are. All right, so what each of these would be as their final answer. Some of these might need to be multiplied to whole. I can't remember, but at least you have the answers. So that is empirical formula. Make sure that you're following the poem for this one. All right, everyone. Thank you.